Hello, so in today's video, we're going to do a summary of SOHCAHTOA. So you probably would have seen these functions before. So sin, cos, and tan. So sine, cosine, tangent. So these are called trigonometric functions. So they're functions that arise from right angle triangles. So you would have probably seen this before. So consider a right angle triangle. You've got a right angle triangle with an angle theta there. Then the sine of theta, the sine of this argument theta, is the opposite side divided by your hypotenuse. So it's the ratio of your opposite side and your hypotenuse of a right angle triangle. Your cosine is the ratio of your adjacent side and your hypotenuse. So it's your adjacent length divided by the size of your hypotenuse. And the tangent of theta, the tangent of a particular angle in a right angle triangle, is defined to be the opposite side divided by the adjacent side. So you can use this kind of SOHCAHTOA notation. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is adjacent, sorry, opposite over adjacent. So using the SOHCAHTOA acronym, you can kind of get these formulas there. So they're just like three key definitions in trigonometry to know. And just one fact that I'm going to mention, and I'll mention this now, is that tan theta is exactly the same as sin theta divided by cos theta. So why is this true? Well, if you do sine theta divided by cos theta, let me just make my writing smaller so I can keep this all on the same page. So if I do sine theta divided by cos theta, so let's do like a proof down here of that. So proof this, or proof of this. So sin theta is just the opposite divided by hypotenuse. Cos theta is the adjacent divided by hypotenuse. So that means that sin theta divided by cos theta is equal to opposite over hypotenuse divided by adjacent over hypotenuse. Now, when you divide fractions, you keep the first one, you change the second, you change to a time sign, and then you flip the last fraction. So you'll get opposite over hypotenuse multiplied by hypotenuse over adjacent. And now the hypotenuses cancel out because when you times fractions, this is top times top, bottom times bottom. So you get opposite over adjacent when you divide sin with cos. And that is exactly the same as tan theta by definition, by the definition of tan theta up there. So therefore, that's how we can show that sin divided by cos is the same as tan. So that's just a little fact to be aware of that we will need in the future. So let's think about, you may have seen this before where you can kind of draw like a unit circle. So basically a unit circle is just a circle with radius 1. So a circle with radius equal to 1. So, I mean, you could draw like a circle that goes all the way around here. And this has got a radius of 1. I'm just going to pick a random point up there on the circumference of this circle. And this has got a radius of 1. So we can calculate the x and y coordinates using SOHCAHTOA. So what we've got here is you've actually got a right angle triangle. It's got a right angle triangle there. And x is our bottom length. So if we call that angle there theta, let's call that angle theta. Then using SOHCAHTOA, we know that sine theta is equal to the opposite side. So the opposite in this case is the height of the triangle, this height of this right angle triangle here. And the height is going to be y. So sine theta is going to be y divided by the hypotenuse. So the hypotenuse of this triangle is 1. So in this case, sine theta equals y. So in with a circle, when you've got a circle with a radius of 1, then sine of this angle here going anti-clockwise, so starting from your x-axis and going around anti-clockwise, if you measure that angle there and do sine of that angle, that's going to be equal to your y-coordinate on your circle of a circle with a radius of 1. Now, the x-coordinate, well, if we think about cos, so cos is adjacent divided by hypotenuse. The adjacent is the width of your base of your triangle, so that's going to be x, your x-coordinate, divided by your hypotenuse 1. So therefore, cos theta is going to be equal to just x with a circle with a radius of 1. So if you have, again, a circle, radius of 1, pick a random point on the circumference, then cos of the angle starting from your x-axis in the positive in the first quadrant, going around anti-clockwise, cos of that angle will be your x coordinate, and sine of that angle will be your y coordinate. So if we think about tan, tan is going to be equal to opposite over adjacent. So tan theta opposite over adjacent. So basically y divided by x. So y over x. So this is basically your gradient of this line here. So the gradient of this red line. So gradient of red line. So the gradient of your radius line. So radius line. So that's just like how you can get these sine and cos values on a unit circle with a radius of 1. Now, how about if you've got like a radius of r? So let's think about the sine and cos functions when you have an angle of theta between 0 and 90 degrees. So obviously this is 90 degrees. 0 degrees would just be the flat line down there. So if you've got an angle of theta between 0 and 90, then we can see that cos, again, using our sin and cos, so we start with actually sin first. So sin theta is opposite. If I just call this the y coordinate there, if I call that the x coordinate, so sin theta is going to be opposite, so the y value divided by the hypotenuse, the r value. So this is going to be positive. So this is greater than 0 when theta is between 0 and 90. Now think about cos. So cos is going to be, in this case, the adjacent x divided by the radius, and again this is greater than 0. So when the angle of your the angle you're measuring, if it's between 0 and 90, if you plug that into sine and cos, you'll get positive numbers. And remember, tan is just your gradient of the radius. So the tan theta is going to be the opposite over the adjacent, so the y over x, which is positive because your gradient here is a positive gradient. The gradient of this line there is a positive gradient. Now let's think about if the angle is between 90 and 180. So if your angle is between 90 and 180, so again, you've got an x value there, you've got a y value. We can see the x value is going to be negative. So that means that cos theta, again, is adjacent. So the x value over the radius, we'll call that radius r. So again, this is a radius because this is a circle of radius r. So I'm just picking a random point on that circle. So that's why I'm calling that the radius with a radius of r. So cos theta this time is negative because x is negative there, but sine theta is still positive. So when you put an angle into your calculator between 90 and 180, sine theta will be a positive number still, but your cos theta is now going to be a negative number, as we can see by the graph here. So that means that your tan theta is also going to be negative as well. And we can see that because the gradient of this radius line here is actually a negative gradient. So we know that tan theta, y over x, is going to be a negative gradient. So we know that too when theta is between 90 and 180. Now let's think about the angle when theta is between 180 and 270. So this time they're both negative. So your x coordinate there on the x-axis is negative. Your y coordinate there is negative. Your radius is still your radius. So sine theta, again, opposite over hypotenuse. So that's going to be y over the radius. Now this is negative because your y value is negative. Your radius is always positive. Radiuses can't be negative. So it's going to be a negative value. And then cos theta divided by cos theta is your adjacent divided by your hypotenuse, your x value over your radius. Again, this is negative because you've got a negative x value there. So when your angle that you put into your calculator is between 180 and 270, sin and cos of that angle will be negative, but tan this time is now going to be positive. And we can see that because the gradient of this radius line there is positive. So a negative, and also a negative divided by a negative is a positive. Sin divided by cos, negative divided by negative gets you a positive. So tan theta is going to be a positive value. So y divided by x is positive. Specifically when your theta, when this number is between 180 and 270, tan will be positive, but sin and cos will be negative. And the last example is when your angle is this big reflex angle, 270 up to 360. So again, sin theta. So you've got an x value there, a positive x value on this coordinate there. You've got a negative y value here. And sin is, remember, your y value over your radius. So again, if we call this a radius of r, this length there. So it's opposite y over adjacent, sorry, hypotenuse r. this is going to be negative, and we can see that because y is negative on the y-axis. And cos theta, this time is positive because we've got a positive x value. So cos theta, adjacent divided by hypotenuse. Your adjacent is x, your hypotenuse are both positive numbers. This is going to be positive when theta is between 270 degrees and 360 degrees. But when theta is also between 270 and 360, tan theta is going to be negative because we've got y divided by x, your gradient of this line. We can see it's a negative gradient, so we know tan theta is going to be negative, and we can see that again because sin theta is negative. Do a negative number divided by this positive cos number. Negative divided by positive gives you a negative, so we know that this is going to be negative, and we can see that again by the graph here. So that's just a summary of how you can use SOHCAHTOA to work out to work out angles and to work out ratios in a triangle, and also the unit circle, and also a circle radius 1 as well. So really, you can use these sin and cos functions to use to do something called polar coordinates, or to use a coordinate system called polar coordinates rather than the x and y coordinates. But you don't need to know about that for the A-level course. But if you were to define coordinates on this XY plane in terms of a radius and an angle theta going anti-clockwise, you can use something called polar coordinates, but we don't worry about that in the A-level course. We only worry about x and y coordinates, and also parametric coordinates as well, but we'll come on to that in future videos. But yeah, so today was just a summary of SOHCAHTOA and how you can determine whether sin, cos, and tan will be negative for different angles between 0 degrees up to 360 degrees.